events. So in the next hour or so, possibly less, I will be talking about real estate valuation as a driver for wealth inequality, evidence from Belgian real estate at Post. This is a joint work with Paula Gobi over there in the audience, who will answer all my questions, right? That's our agreement. David Kaminski, who's at Element 61, and Glenn Magerman, who couldn't make it today. Before diving into the project, I would like to give you a disclaimer, and that is that in this project, as the title suggests, we are primarily interested in studying wealth inequality through the lens of real estate using a wide variety of sources. One of these sources is the Belgian cadastre data, which is a data set that's extremely detailed and confidential, as it includes a bunch of very nice features about the state of real estate in the country. Because of the confidentiality, we had to sign an agreement with the National Bank of Belgium back in March, and despite that, we still have not been able to access this data. Hopefully, in the next session, we will have this data and we'll be able to provide more complete results. On the light of that, today, we're going to be focusing on inequality through the lens of real estate using Belgian at Post from a very popular website in the country. So that means that the presentation is going to be possibly shorter than 1 hour, which is unfortunate because we're not able to give you the complete picture. But on the bright side, we'll probably have our coffee break sooner, so that's not so bad. Okay. Finally, let me dive into the project by giving you some motivation on why we should look at real estate if we're interested in studying inequality. And I will give you 4 facts to motivate our choice. The first and possibly the most important fact is that real estate is one of the main components of household assets and debt portfolios. In Belgium, this is for Belgium, but it's also true throughout many countries, at least in the West. So these 2 charts here show results from the Household of Finance and Consumption Survey, which is a survey from the National Bank of Belgium, and basically show you that throughout the income distribution, real estate, which is in the pie charts, the areas with gray color and green color, represent the majority of both assets on the top of the chart and debt in the bottom of the chart. So if we're looking at assets, for example, we see that this relative important ranges from between 70% in the bottom of the income distribution to close to 95% in, for example, the 4th quintile. The same is true if we look at debts. Actually, the percentages there seem to be quite higher, ranging between 90–95% in most of the cases. So, this is to say that if we're interested in wealth inequality, and that's one of our interests here, then real estate is clearly a very important component, right? So that gives you our first reason to use real estate to study wealth inequality. Then, on the top of this very obvious reason, I want to give you like 3 additional reasons, which are the following. So first of all, homogeneity in the data, right? So if we're interested in this real estate data, and here I'm thinking mostly in the cadastre, right, which is a data set that exists, which is a type of data that exists for several countries, then this type of data is typically very homogeneous across countries. And let me just give you two examples. So first of all, a square meter in Belgium is the same as a square meter in the United States. The only difference is that they call it square footage there, but it's the same after converting it, right? So this is really comparable across these different contexts. And then the second advantage of this homogeneity is that with the cadastre, we typically have access to the universe of real estate in the country, and therefore selection, which might be an issue if we look at surveys, for example, is never going to be an issue, right? So this is our second additional reason to focus on real estate. The third reason is the sensitivity to administrative boundaries, right? So for example, if we know where the house is located, because we have the coordinates, then we can tell whether this house is in province X, commune X, a statistical sector X, or continent or region X, right? Because we know the exact location. And that might be important if we are interested in zooming in within countries, right? So this geolocation feature of this type of data makes it very convenient to study within country heterogeneity. Finally, the fourth reason is that if we observe the year of construction of real estate, we can potentially go back over time easily because we know the location, we know the year of construction of the real estate, so therefore we can potentially look at an area at any point in time and look at the characteristics in that area in that moment in time, right? This bullet point is something we're not going to explore today in detail, but that's a possibility, a potential that has this type of data. Okay, so now I gave you the 4 reasons why real estate is interesting if we want to study inequality. So now what were we going to do in this paper specifically? Well, so as I anticipated, the goal is going to be, mostly in a descriptive manner, to comprehensively study wealth inequality in Belgium through the lens of real estate. And for that, we're going to exploit this geolocation feature of data, both from the cadastre, which we still do not have, and from the listings, sales and rentals that we are going to use today. From this data, we are going to produce several measures of inequality because, as we discussed in the morning, people like the Gini, but some people do not like the Gini, so we're going to offer a menu of inequality measures, and then you choose your preferred. And we're going to exploit this feature about the geolocation to look at different levels of aggregation. So we're going to give you a number for Belgium, but we're also going to tell you how unequal is Brussels, how unequal is Wallonia, and how unequal is Flanders. And we're even going to deeper into that. Then the big chunk of the presentation today is showing you our results with maps. So you're going to see lots of maps of Belgium. So this is good for people like me that are still not very versed on Belgian geography. And finally, in the most preliminary part of this preliminary presentation, we're going to try to understand what are the correlations at relatively low levels of aggregation between our inequality estimates and some of the obvious covariates, such as income and population density, right? So that's like the 4th bullet point in the in the 1st bullet point, right? And so even more preliminary, in the end, we're going to try to get a little bit more causal and try to understand whether housing policies can have an impact on inequality estimates at low levels of aggregation. And this, as I mentioned in the slides in parentheses, this is going to be a teaser, right? So we're going to tell you we have these things in mind and we have these methodologies in mind. We're going to probably do this in the future, right? So this is our agenda. Today, results. So we're going to, if you want to keep a number in mind, so we're going to tell you that housing value inequality with the Gini index in Belgium, according to our estimates, is 0.28. We do not find substantial heterogeneity between rentals and sales on this popular website. But we do find that there is significant heterogeneity depending on the level of aggregation that we look at. So the more we zoom in, then the disparities become more obvious. Then on the correlations part, which is again very descriptive, we're going to show that housing value inequality is positively correlated with housing value. So more expensive houses, more inequality in housing value. And population density, more people in general, more inequality. And a negative correlation with income. More income, less inequality, according to our preliminary estimates. Now, the last bullet point here is important because we want to be upfront about this, right? So we are aware that our results might be subject to an important concern, which is the representativity of the sample, right? So we have information on these listings, on all the listings. I'm going to go into the details of our data in a second, but we're aware that this sample might not be representative, right? And that might be a shortcoming of what I'm going to show you today. But we also want to bring to your attention that this is something that we'll probably be able to solve once we have this cadastral data, because we're going to be able to see how representative is the sample that I'm going to show you today, right? So despite this might be an issue today, we have ways to address it in the future. But keep that in mind when you interpret our results. Okay, so That was a very broad overview of what we're going to do today. Now let me dig into the details. I start talking about our data. Right? So as I anticipated, today we're going to use data from an online platform with rental ads and sales. Right? I think I'm not allowed to say the name of this specific website, but let me just say that's a popular one that you probably know. From this website, we have been able to scrape all the listings since July 2020 until April 22. In fact, Glenn, one of the co-authors in the project, is still scraping. So we're going to have more listings in the next presentation. And this in total are about 500,000 ads, sales, and rentals. From each of these listings, we're going to be able to observe like the typical variables that you see in this website. So we're going to see a price, the number of rooms, number of bathrooms, terrace, parking, etc. And as I anticipated, like one of the cool features that we want to exploit is that we have the latitude and longitude of each of these listings, so we know where this thing is, this house or this apartment is. And this is what we're going to use today. Soon, in the future, hopefully before I finish my postdoc at ULB, we're going to have access to the Belgian cadastre, and that is a very detailed data set with information on all the universe, also on the universe of real estate, plus all transactions since 2008 with prices. That's extremely rich and data set, and that's probably why it's so hard to access it. Yeah, so that's it. Now, descriptive. So I'm showing you like our listings data, right? So we have 250,000 of the listings are sales, 150,000 are rentals. If you look at price, and price is going to be euros for rentals and thousands of euros for sales, we see that the average sale price in Belgium is about 350,000 euros. Average rental price is close to 1,000. The space, sales seem to be bigger than rentals. Year of construction is usually 1977 for sales, 1985 for rentals, and then you have like other characteristics that I think might be of interest here. You can see that a big chunk of the listings are, I have the pointer, a big proportion of the listings are in Brussels, 8% of the sales and 26% of the rentals, and also in Antwerp, around 12% of the sample from both sales and rentals. I can show you this distribution in a map, but and I was like really struggling on how to do this map in a way that doesn't look too bad, because as you can see, like there is a high proportion of our listings in the city. So this is Brussels, this is Liège, I think. This is Ghent, and Bruges is somewhere over there, right? Yeah, I learned a lot. And so you have a big proportion of listings in these areas. Then in the rest of the country, there is not that much. How representative is that? Well, with the cadastral data, I'm going to tell you whether this is similar or not. But this is how our data looks like for the moment. Okay, but we have like listings pretty much everywhere, except like these gray areas. I don't know if you can see very well from the back, but pretty much all the country is covered. Okay, good. So this is how our data looks like. Now we want to study inequality. And of course, now we have an issue because we have listings from July 2020 and listings from April 2022. And these two types of listings are not directly comparable, right? Because there is something called inflation that means that the prices are changing over time. So and that's been especially important in the recent months. Therefore, we have to at least adjust the listings for inflation, right? So this is one of the reasons why we cannot compare the two things at the same time, right? The other issue that we have with this data, if we want to study housing value inequality, is that rentals are prices per month, whereas sales are the value of the whole house, right? So we have to somehow adjust by either converting the rental prices to sale prices or the sale prices to rental prices, right? And so we have these two challenges, and this is to say that what we had to do is to essentially predict the value of each dwelling in our data to a value at a given point in time. That's going to be April 22, right? So we're going to look at all the listings, look at the characteristics, and try to predict how much this house or this apartment costs as of last month. Right? We're going to do this, and that's an important part of the project. And we're going to do this prediction using two different methodologies. The first methodology is these hedonic regressions. So these are simple OLS regressions, essentially, where on the left-hand side of an equation you have the log price, and on the right-hand side of the equation you have a bunch of like dwelling characteristics such as number of rooms, etc., etc. So this is a simple OLS regression, and it has a big advantage that it's very transparent, and so it's very easy where the variation is coming from and what drives the value of the house, right? So we use this essentially to check that all the signs are right on our data, right? So if we were running these hedonic regressions and we found that the smaller the house, the higher the price, that would be like a red flag, right? It means something must be wrong. So that's why we use this as a first step to predict the value of the house. We don't end up with these hedonic regressions because we know from the literature that although they are intuitive, there are a bunch of methods that are technically superior, at least in terms of predictive power, which is where our second methodology comes in here. So in addition to predict the prices with hedonic regressions, we're going to use some machine learning techniques to get at the predicted value of the house as of April 2022. As I mentioned, like this has the big advantage that we know that's a fact that they have more predictive power, but the shortcoming is that the methodologies are sometimes more a bit of a black box in the sense that we do not understand where the prediction is coming from. So that's good. That's why it's good to complement this with the first step in our estimation process. We're going to try a different set of methodologies. Our preferred methodology is going to be something called XGG boost, which are a type of boosted trees. I'm going to give you the details in 2 slides. And in the end, the numbers obtained from this type of predictions are going to be our predicted values of the house, and all the inequality estimates that I'm going to show you just after that section in the presentation will come from those predictions with these machine learning methods. Okay, so on the details, just a little bit. For the hedonic regressions, let me just say that as I mentioned, these are OLS regressions, where on the left-hand side you have log price, on the right-hand side we're going to include all of these covariates there. So these are, living area, surface, frontage, parking, etc. Information on the location, energy consumption, month and year fixed effect, district fixed effects, and these variables. So we put all of these into a regression, and the results are that the measured determinants, according to this methodology, are location. So if you're in Brussels, it's important. Well, basically, these districts have very high predictive power, like the space of the dwelling, so how big they are, number of rooms, bathrooms, frontages, and parking. So these are some of the most important variables according to our methodology. We get an R2 of 0.62. Okay, so this is the first step. Now, on what we actually do in the end, and let me in advance apologize for like this chart. I don't think you can read it. I could barely read it myself being in front of it, but for the next presentation it's going to look better. So so this chart basically summarizes our methodology with this XGG boost. And here I just want to give you the basic intuition on how this thing works and where the numbers are going to come from, right? So, so the idea of these boosted trees is similar to random forest and this type of trees algorithms. And so basically the idea is to try to predict the value, partitioning the covariate space in different methods, right? So basically you're telling the algorithm, okay, algorithm, suppose you have to choose one variable so suppose you want to predict this value of this house. And you can only choose one variable that will tell me, that should help you in making this prediction. Which variable are you going to choose? Right? So this is the question that the researcher poses to this algorithm. And then the algorithm says, okay, the most important variable should be whether the listing is in Brussels or not. So there says district Brussels there. So that's the variable that the algorithm would tell you. So that, according to that really determines a big chunk of the variation in prices. Right, so this is the first variable. Then, if you are yes, you're in this side of the tree. If you say no, you're in this right-hand side of the tree. And then basically you repeat, then ask the same question. Okay, now suppose you're in Brussels. What's the second most important variable to determine the predicted value of a house? So the tree says, okay, now it's the number of bedrooms. So in particular, whether the house or the apartment has more or less than 1.5 bedrooms or not, right? And that's the same if you're not in Brussels by chance, right? And then you go on and so forth, and the third variable is living area, which is a space. And then you can go on and ask and ask and ask and ask. And of course, in the end of the day, you're going to have very similar listings in the leaves of the tree, which are like this part here, like it's the very end. You could think that in the very end, in the most extreme case, you could basically partition the sample such that in every leaf there is one observation. So of course, you could totally predict the value of the tree if you overfeed the model in such a way, right? So then the difficulty comes in how to cut the tree somehow. And that's something the algorithm takes into account. Okay, Bart. Yes.
If I have the same house, more expensive in one location than in another, how does it reflect inequality? And consider this being something unequal. Just expecting the houses in different have a different price. Taken into account.
Oh, that's a good question. So I would say that, at this stage, I'm talking about how you predict prices, right? Which is one thing I'm dealing with. You're going further, so that's a very advanced question. You're telling me, okay, suppose I believe your predictions, and you're telling me that these two houses that are similar have, I don't know if similar or the same value. How will this enter into inequality? Right? That's your question. Then the answer is that, well, so if you're looking at inequality at the country level, the two houses will be taken into account in the same way. So they are the same, they have the same weight, because we're interested in obtaining a number at the country level, right? If we want to dig deeper into the regions or the geography of Belgium, then we're going to like separate this type of houses, right? We're not going to take into account, because we're going to study inequality separately for example, in the Flanders region than in the Wallonia region. So these two houses are going to be like different in the sense that they are not going to be computed for our Gini estimate at the regional level. Does this answer your question? Uh-huh. Okay. I mean, if the value is different, then the owner of the house in Leuven or in Brussels is going to be wealthier, right? There is a question there? Yeah, I think that's an excellent point, like both the question and the answer to your question. So thanks for helping me in providing a very good answer. So I think that you're essentially give an answer, right? So the Bart was like bringing up like differences in amenities as a potential driver for value of the house, right? And of course, we're not explicitly modeling this in our either OLS hedonic regressions or the tree, right? Of course, I suppose that these would be like variables that would enter with a high predictive power. In our approach, simply deals with them with these district fixed effects, location fixed effects, and the latitude and longitude, right? So to some degree, these geographic identifiers are capturing differences in amenities across different locations, right? We're not getting at the exact variables defining this amenity, but they are captured there in the prediction. I think that for the future versions of in this project, and because all areas are areas that are continuously improving, right? So you're suggesting like ways to make our prediction better, which I think is something we definitely need to do as well. We're going to try to incorporate some variables describing local amenities into our regressions, and that should, I think, take into account like Bart's question. But in this presentation today, it's not that we're completely ignoring them completely, right? Because they are taken into account with our geographic identifiers. I think that's what I wanted to say. Okay. Okay. So I more or less describe. Is there any other question? No. So I think I more or less describe how this tree thing work, right? So you basically grow the tree, and at some point you have to decide where to cut the tree, so where to stop partitioning the covariate space, and that's something that the algorithm decides with some instructions, right? And so we do this, and our prediction error is like between 16 and 25%, which is good, but I think we can do better, potentially by including some of these amenity controls. We could like bring down this prediction error by a little bit more. But in the end of the day, even though we do this like fancy methodology, the correlation between our basic OLS predictions and boosted trees is pretty high. So we get that correlations are between 82 and 87%. So that means that the basic OLS is not that bad, right? But in the end of the day, we're going to rely on these predictions to get at the inequality estimates, which come next, right? Well, before there is this slide. So in this slide, I'm showing you the distribution of housing value according to our estimates across Belgium, right? So in this map and in all the maps, so remember this color scale, brighter colors are going to denote higher values of either housing value or higher inequality, right? In this case, is housing value in thousands of euros. Darker values are going to denote darker colors are going to denote lower values, right? So we can see that according to our estimates, the houses are more expensive in Brussels, I think this is around Ghent, like Bruges is somewhere here. I don't know what's that. Croquet. I'm sorry, I still don't know this so much geography. And this is close to Luxembourg. So, and Wallonia is, the values in Wallonia are slightly lower. Yeah, you have a question? No, so I'm just plotting the raw predictions. So this map literally tells you that in Brussels, in this postal district of Brussels, an average house costs somewhere between, that's about 500, half a million euros more or less. That's what it tells us. Whereas in, for example, this area of Wallonia, the average value, is the median value? The median value of a house is somewhere around 200,000 euros. Okay. Yeah, so that's the last part of the project where we're going to explore some correlations, right? So right now I'm just telling you, okay, these are our predicted values of the house. From that, what is our estimate of housing value inequality? First in Belgium, then in the regions, then in the provinces, then I'm going to go down, 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 down until the statistical sector level. And then in the last part of the presentation, I'm going to like do some very basic correlations to see what are some of the determinants in a purely descriptive way of like our inequality estimates. So I think you're essentially anticipating very much what I'm going to do later on in this presentation. Good. So that shows our estimates of housing value. And I have until 2:30, right? Yes. Okay, good. Okay. Yes. Yeah, no. So these are predicted as of April 2022. That's what I was telling you. I cannot compare the listing from July 2020, which is our first month data, with a listing from April 22 because there has been a lot of inflation, right? So these are our predictions in housing value for all of the dwellings in our data set as of April 2022. And we could potentially do any other month in this time period. Yes. I think that's a concern. So for right now, again, it's only descriptive. In the last part of the presentation, we're trying to understand like what could be the drivers of inequality. And so these are mostly going to be outlines for next steps. We're going to look at the specific policies. So for example, we have in mind like changes in the registration fees, and we're going to try to see whether these have an impact on the types of houses in the market and on the values. But again, this is like the very last 2 slides of this presentation, getting at your point. Okay.
These are us.
Exactly. Exactly. So we expect this to be overestimate the actual value of the house. It's the most likely scenario. With the cadastral data, since we'll have the transactions, we'll be able to see how big is the difference between the ask price and the final market price. Yes. And I think that these are like potential interesting spin-off potentially for this project, right? Because I think it's already the scope is potentially already too wide, but this I think that's an obvious spin-off and with lots of interesting implications for policy. Okay, so this is the value. Now we can finally start telling you about inequality at different levels of aggregation. Before there is one last slide. So what are we going to show you in the next set of slides with the results about inequality? Well, so first, our main focus is going to be inequality in housing value, which is like the map I just showed you. But we're also going to look at space. So these are all slides in the appendix if you're interested. But we think that looking at space is also interesting for this following reason. So the first, as I mentioned, space is something that's universally homogeneous across countries. A square meter in Belgium is the same as square meter in the US. Second, at low levels of aggregation, especially how the space is one of the major predictors of the value, right? So if we have a granular focus, like looking at space is very similar to looking at value, which is like the third bullet point actually. And the last point is that we don't need to rely on prediction. So if we don't believe this machine learning methodology or whatever, then okay, look at space. That's something that comes from the raw data. So that's something that we just look on the site. Yes.
I still try to make sense of the use of the inequality because maybe later in the cadastral data you look, you have no personal characteristics. So you could as well replace everywhere in all the slides inequality by variance. It's purely statistical, well, it's variance that you're describing in housing value.
Yes, exactly.
If you reserve inequality for studying how important this variance is for natural persons or households. Is that right?
Yeah, I think that's a...
Link it with individual characteristics or income characteristics?
No, right now we're not linking with individual characteristics. I think that's a valid point, and that's something we're currently discussing ourselves, right? So how do you interpret our inequality estimates that we're going to show you next, right? So the literal thing we're going to show you is variation in predicted house value. How do you interpret this variation in a predicted house value? Well, one interpretation is inequality and wealth. Another interpretation is that you're actually capturing variation in housing consumption, which might be something different, right? So if you believe that, for example, you're spending a fraction of your income on housing, independently on your percentile of the distribution, then this is actually something closer to income inequality. if we were trying to make a distinction between renters and homeowners, then maybe we would get to something closer to actual wealth inequality. So these are like things that, like basically I'm describing like potential interpretations of potential results, of the results I'm going to show you, which are, I think, valid and they're very much under discussion. So feedback on these things, I think will be very much appreciated, because we have started working on basically trying to differentiate along these dimensions of rentals versus owners and these type of things. Okay, so subject to this interpretation, right? We're going to look at inequality in value in space. Then we're going to look at different levels of aggregations, as I anticipated 100 times, from the county level until a very disaggregated way to look at inequality, which is inequality around buildings. And I'll give you the details in 3 slides or 4. And then we're going to produce a bunch of inequality estimates. Our preferred measure will be the Gini, just because it's the gold standard in the literature, but of course we are aware of some criticism. Some people don't like it, so we're going to show you as well some ratios and other things, and also the compositions along sales and rentals, etc. Okay, now finally on the numbers. So our, as I also anticipated in the preview of the results, the housing value inequality in Belgium, according to our estimate, is 0.28. So this is the number in inequality in housing value. If you want to compare with other countries, well, in the morning we had a bunch of presentations, but there is difference between pre-tax, post-tax. We had the last presentation was all about this, but for example, the post-tax income Gini is 0.26 according to the OECD report in 2016. If you want to see other measures, you have the 1950 ratio, which tells you that a house in the 90th percentile costs almost twice as a house in the median, right? And you can choose your own. If you look at a space, inequality in space, then that seems to be more inequality, 0.35. Then that's the top part of the table. In the bottom part, we try to see whether these inequality estimates could be driven by, for example, the listings that are rentals being different from the listings that are sales. And based on standard Gini decompositions or the tail decomposition, it seems that in general, the 2 types of listings are quite similar, in the sense that most of the variation comes from within the listing type and not between. And this is what you can see in this number here, right? Okay, so this is the number for Belgium. Now we're going to, as I promised, we're going to dig deeper and try to see whether there are important differences across different levels of aggregation. Okay, so first the regions. So we have 3 regions in Belgium: Brussels, Flanders, Wallonia. The Gini within these regions, the value Gini within this region is 0.20, almost 0.3 for Brussels, Flanders 0.25, and Wallonia 0.28. There are these discompositions here. There are some discrepancy. It seems that most of the variation comes from within these regions, but between 10 and 30% of the regions of the variation comes from differences across the regions. So this is regions. We can do provinces, and so here the numbers also change. I did not give you the numbers for each of the provinces, but remember that lighter colors means more inequality and darker color means less inequality. So again, Brussels is relatively unequal. This province here, which is west of Flanders. So that's pretty unequal. There is a lot of inequality in this. And this is the middle of Flanders province, or what's the name of? So, sorry about that. That was a bad joke. Not to make in Belgium. And this is the east of Flanders? Limburg. So these are relatively unequal provinces. And so we can zoom in even more. Bruges? Antwerp. But okay, I have a map on Antwerp specifically. I will show you. I was not planning to, but I will show you. So we can zoom in even more. And now we have the inequality variation at the postal code level. And so here the colors change a little bit. It seems that this is relatively unequal. Now this area seems more unequal. And finally, the statistical sector, which is a mess. It is a mess, right? And with a lot of empty areas. So if you remember, like my warning on the representativity of the sample, this is where it's possibly very important, right? We're really not sure. Possibly it's not representative at this level of aggregation, right? So this is something to take into account. We know, we're aware, and with a cadastre, we'll see whether the actual map looks like this or it is very different from this. Now, there was a question, Bart? Yeah. Yeah.
So it means that overlap in the different units, like inequality, due to the overlap between the different provinces, more and more important to shrink down your units. So what is the word in terms of it? It's 90% within, and the Gini says it's 30% within. What is it?
Well, I think it's worthy because if you're interested in understanding like local disparities, right? So if you're only interested in one number at the country level, yes, of course, just get the 0.28. But inequality at the local level might determine a bunch of outcomes. Right? Yes. Yeah. Yeah, you're pointing at the differences between the Gini and the tail, right? Well, but this is like it's not the inequality at this, so I'm decomposing at the national level. Exactly. So, yeah, I don't know. That's a good question. To be honest, yeah, I think it's clear that the Gini and the tail are telling different stories, and that's something we have to understand why. But I think it's worth like doing this decomposition to understand like where the variation is coming from. Then, yes. Yeah, exactly. So the residual is very important, especially the more, I mean, I'm just giving you like the numbers here just for the sake of completeness. I understand that, the residual becomes extremely important at this level of aggregation, but I mean, I showed you these numbers before, so I want to give you the same numbers now. Understanding why the residual grows so much, that's something we have to do. Okay, so I was in this map. Okay, 15 minutes left. So this is at the country level. I warned you that this is possibly not the best map of the world because representativity might be a big issue there. So one thing we can do is like look at cities. Like if we want to zoom in so much, we have to look at cities where different areas are more covered. So this is what we did for Brussels, right? So it's like the same type of map, but now it's Brussels only. It's a statistical sector. So this is telling us that inequality is slightly larger in these areas around Avenue Louise, St. Gilles, Châtellon. It seems to be slightly lower on the outskirts. Now, I have the same map for Antwerp. So this is Antwerp. The central area seems to be also more unequal than the outskirts. And since we're in Leuven, I also have the same map for Leuven. This is how it looks. I think we're somewhere here, right? So this is a relatively unequal area according to our estimates. Okay, good. Now, on the last measure we're going to introduce today, right? So you know, the title of the slide tells everything I want to say. So when we want to look at this very fine level of aggregation, then assuming you have a representative sample, then administrative boundaries might be an issue. And why is that? So let's look at this map and let's think of somebody living in, for example, this statistical sector here, which according to our estimates is very unequal, and somebody living just next to the other side of this border, right, in this other statistical sector that is very unequal according to our estimates, right? So if we're interested in this level of aggregation and we're comparing somebody living just across the border, then we're likely going to get at a different conclusion, right? Because of this arbitrary definition of the administrative boundaries. On the top of that, the shape also changes a lot, right? So these boundaries are huge, whereas like some of the boundaries in the center are very small, right? So that's a problem if we want to look at this fine level of aggregation. And so for that, the last measure that we're going to introduce in this project is a measure of inequality that is independent of administrative boundaries, because it will vary at the building level. And here I just want to give you the intuition, right? So suppose that we want to understand how unequal is the local neighborhood of a given house or a given building, right? So one thing we can do, and we did, is to take one building, for example, this one here in green, and then just draw a circle around that building and say that all the dwellings or listings in this case are the actual local neighborhood of that specific building. And then once we have this local neighborhood defined, that doesn't depend on any existing administrative boundary, we can compute, for example, the Gini index. And that's what we're going to call local neighborhood Gini, right? So we can do this for this building and for the rest of the buildings in the city, and then we can get something like this. So each of these dots here represents a building in our data, and the color represents the inequality around that building, right? So what we can see is, again, is similar to what we saw before, that these areas around Avenue Louise and St. Gilles are relatively more unequal, and the outskirts are somehow less unequal. And again, the advantage of doing this type of thing is that we do not depend on administrative boundaries. I have the same map for Antwerp. This is how it looks. And I have the same map for Leuven, which looks like this. Okay. All right. Now, so this is the last inequality measure. Now we're going to go into the determinants. Oh, sorry. Yes, exactly. So this literally captures these parities. Yes, yes, possibly. It's very possible. At the low level. Yeah, it's very possible. Exactly. So, I mean, this literally looks at the disparities around a house because you might be interested in something very local, right? And if you want that, we're offering you a way to, look at the effects of inequality on whatever thing you're interested at. There was a question in the back first. Yes. Yes, I think that's a valid point. As I think we discussed, this is what we're showing you are literally the discrepancies in housing value at different levels of aggregation. The way you want to interpret these measures, well, so there is some leeway there. So one interpretation, as you're suggesting, is differences in housing consumption and at low levels of aggregation that might maybe not make sense, maybe. But you might be interested in some outcome that is determined at a very local level of aggregation. I'm thinking about crime, for example, or perceptions about things if people extrapolate from their neighborhoods, right? So if you're interested in this kind of research question, having a measure that has this level of granularity might be important. Of course, the interpretation is always a caveat, I think, to bear in mind. Yes? I think. Yeah, I think that you're getting at a similar point on segregation, right? I think you're saying, okay, if you have segregation, you're going to have low levels of inequality at these levels of aggregation. If you do not have segregation, so if you have diversity, then each of these dots should be very similar to the country as a whole or the city as a whole, right? So the fact that we see variation at this level of aggregation is probably telling us that there is some segregation going on in the city, at least on income. Is this what you have in mind? Okay. Mm-hmm. Mm-hmm. Yes. Yeah. So these were lots of comments. I would just say that I would be very careful before making a statement of the sort, segregation is very good or is very bad, because it's a controversial thing. I think you're raising very important points. I only have 10 minutes left, so if you don't mind, maybe we can postpone our discussion after this conference, because I think after the talk, because I won't have time to show you the rest. I mean, I would definitely won't have time to show you the rest. So let me just speed up on the correlations and then just show you like the teaser on this more causal part we had in mind. Right, so the very last thing that we do in this descriptive part, so well, now I showcase all the inequality estimates that we produce, which are a lot at different levels of aggregation. The last thing we do in this descriptive part is like look at just very basic correlations. For the moment at the statistical sector level, then we have to, of course, expand this to more covariates and more levels of aggregation and see if we find any pattern. That's the objective in this part of the paper. But yeah, so in this table, basically, I'm showing you the correlations between. This is the last measure of inequality that I showed you at the statistical level, and housing value, population, taxable income. And the only thing I want to say is that it seems that there is a positive correlation with housing value, between housing value and inequality. So more expensive houses are typically in more unequal areas. There is a positive correlation with population density. More population translates typically into more inequality. And if we look at taxable income, it seems to be a negative correlation. Between columns 1 and 3 and 4 and 6, basically, we're partitioning the sample between Belgium as a whole and only Brussels. And some signs revert. So this suggests that, looking at urban areas and rural areas might be important. But this could be due to the fact that there are these differences, or it could be to differential selection in our data. That's something we have to explore. And finally, that there are some non-linearities. It seems like the relationship with income is like an inverted U from these table. Yeah, 1 second. If we do the same correlations with the value Gini instead of like these local neighborhood Gini that I show you, like the signs are very similar. Yes, Bart. Is like local neighborhood Gini, like this is like the circle thing, aggregated at the statistical sector. It's the weighted mean, exactly. So for example, if an apartment has 3 listings, so because like this measure varies at the apartment level, right? So if that apartment has 3, if this building has 3 apartments, then this will have a weight of 3, right? Make sense? This is how we do the aggregation. Okay, so that was like the end of this descriptive part. Like to conclude the presentation, as I anticipated, we just want to give you a teaser on some of the things we can do with this wide variety of measures at different levels of aggregation. So why would we be interested in doing something like this? And here we would like to be a little bit more causal in the sense that we are thinking about exploiting some policies that potentially were exogenous in the sense of like unanticipated, and there is like a lot to be discussed there, but that's something we're working on different characteristics, on for example, the value of the house, the predicted value of the house, the number of listings, etc. Right? And because that's something we can do with this listings data, and especially with the cadastral data, like soon. And yeah, as I anticipated, we're going to have like basically 2 different policies in mind. The most important are these changes in the registration fees in Flanders, and then like we also have in mind these mortgage deductions. So just like to give you one policy, so it seems that the Flemish government in September 27, 2021 decided to reduce the registration fees from 5 to 6% to 1 to 3%, depending on a bunch of characteristics, right? So, you know, we have these changes. So this was in Flanders, not in Brussels, for example. So we can potentially use this as a shock in basically the entry value of a home. And see whether this had an impact on the listings in, for example, diff in diff setting. And so we did something that's, again, like that's the most preliminary thing of the whole presentation, and everything was pretty preliminary. But if we look at month 0, which is September 2021, and we look at the lot price, comparing Brussels versus Flanders, so it seems that after the announcement, there was a reduction in the value of prices, and you know, just preceded by an increase in month 3, which is by chance December 2021, which was the month before implementation, right? So it seems that after the announcement, prices went down, then the month before the implementation, it went up again, and then they went down, right? That's one thing we can look at. And finally, the very last thing, just a teaser as well, especially motivating why we want to have like measures at such a local level, right? So one thing we look at is the density of listings, so number of VATs, in both sides of the border, right? Comparing Brussels versus Flanders. So on the right side, you have number of kilometers. On the Flemish side, on the left, you have Brussels. So if you look at the density of listings, so number of VATs, you see that there is a huge jump. So if you're just on the Brussels side, there are very few listings just in the border. And if you just like jump a few meters, then there is a huge jump, right? So this is like a big discontinuity that can potentially tell us that that can potentially be driven by a policy, or maybe the actual map of real estate looks like this. That's something we don't know with this listings data, but we can definitely explore, right? So is this discontinuity driven by the policies or by the actual dwelling density around in both sides of the border? And that's the last teaser. So just to wrap up, because I'm out of time, in today's presentation, we studied inequality in Belgium using online listings from a popular website. The housing value Gini in the whole country of Belgium is 0.28. We didn't find substantial variation between sales and rentals, but we found that there is substantial heterogeneity in the inequality estimates, especially at low levels of aggregation, obviously subject to the caveat of representativity of the sample. We found that there is a positive correlation with housing value, population density, and a negative correlation with income. The 6 point is what I just said. And so in the future, most importantly, we have to add this cadastral data. So we hope to access this data soon, at least before I finish the postdoc. And once we incorporate this data, we're going to complete this descriptive analysis and hopefully be able to study the effects of housing policies on inequality. And this is everything I had to say for today. Thank you very much for listening to me. Thanks.